When we're doing this, remember, you are given specific values. You need to find, in this case, two sides and one angle. Now, yesterday we talked about how angles always have capital letters. Sides opposite those angles use lowercase letters. This one kind of sucks because there's an S, and there's fives, so I apologize. So if we bring this across, here's little r, little t, and little s. Everybody okay with that so far? That means I need to find first, I don't have to do it first, but I have angle t to worry about. I have little side t and little side s. So as I go into that problem then, I start with the information that I was given. Well, I was given one side and one angle. So circle it. I am given an angle and it's side opposite. So right off the top of my head here, if I know an angle and a side opposite, I think about my trig functions. Sine of something is opposite over hypotenuse. Cosine of something is adjacent over hypotenuse. Tangent of something is opposite over adjacent. So right away, since I have an angle and the side opposite, that tells me I'm going to have to use sine and tangent, because those are the two trig functions that have opposites in them. Okay, that's how that works. So therefore, I know that I need to find t. Well, t in this example here would be the what?
Adjacent.
Adjacent, very good. And s is the hypotenuse. So I write it out. The tangent of 57 is 15 over t, which is the adjacent. When the variable is in the bottom of the fraction, we do our good old-fashioned, we do the exchange-o-change-o. Did you flip it by mistake? Do your exchange-o-change-o. And then always write down what you're going to put in the calculator before you do it. Okay? Because if you write that down, that tells me you know what you're doing. If you accidentally type in 17 or 15 over, or let's say you type in 57 over tangent of 15, you get a number, you just write it down, not even thinking about it. It's obviously the wrong value, but if you don't reuse that value, you're going to get the next question right anyway. I might just take off half a point because you pressed the wrong button, but you showed me everything you knew how to do. Okay? Go to the next one. The next one's the hypotenuse, so I have to use the sine. And that's 15 over the hypotenuse. I'm going to write out the hypotenuse part there because it's an S and it just looks awful with all those fives and everything. Is that okay? First hour freaked out when I used the S. Fourth hour when I wrote hypotenuse, they freaked out. So I'm just going to say, I don't care what you think, I'm going to do that. This is being honest. Again, we have an exchange-o-change-o. And then you get your decimals. What did you guys get for t when you put that in? What was it? 974? And what did you get for your hypotenuse? 1789? Everybody agree? And then how do you find out what the angle of t is? The complement. What's the complement to 57? Very good. It's 33. Now, one thing that I will say that a lot of people do, when they do complements like that, the biggest mistake that you will find is people forget that it's 90, they go to 100. Okay? Remember, the complement's going to be at 90. Right? It's a very common problem. And that's how that works. Okay. What's up? Oh. Let's try a different one. When I get to this one, this was 14, I believe, right? When I get to 14, excuse me. I have two sides, and I need to find one side and one angle. Well, the missing side length that I have to get here, is it going to be a hypotenuse or a leg? It's a leg. Little d, little f, and little e. So I have to find that little side d, and I'm going to use Pythagorean theorem. So d squared will be plus 3 squared is 9 squared. Yes, ma'am?
It doesn't matter which one you put as A, B, or C, right?
Nope.
Okay.
Well, see, the hypotenuse is always the largest one. That always has to be across from the right angle. Okay. So 9 squared is 81, 3 squared is 9, 81 minus 9 is 72. So you have d squared, which gives you 6 root 2. Now, your calculators, you guys all have the calculator, it does end up to spit out a 6 root 2. You can leave it like that. If you hit the double arrow button, I think it's 849.
794. Wait, no. 849.
I thought it was 849. So if it says, a lot of times with these problems, it will say round to the nearest hundredth. But I totally understand if the calculator spits out something in a radical, you can leave it. It's not a big deal. And then you fall back to trying to get your angles. So you need to find angle D. You start. If you're at angle D, 3 is the what of the triangle? It's the adjacent. 9 is the hypotenuse. What uses adjacents and hypotenuse then? Cosine. So we started out as the cosine of D is 3/9. When you are to find an angle, when you're trying to find the angle, that's when you have to hit the inverse button. So you inverse cosine of both sides. And then you do, you hit the button and you get 53? 7, wait, my ears are all fogged up.
70.53.
Okay? And then for angle F, you switch places. You move over to angle F and you figure out, well, that value 3 is what to the angle F? It's its opposite now. It's the opposite. When you switch positions, you switch your perspective. This is now an opposite. Hypotenuse doesn't change because it's still always across from the right angle. So you rewrite it. Now it's the sine. And with any luck, you should get 29.47. Right? 19, sorry, I got ahead of I didn't carry the 1. Yeah. The memory was right here, which hurts. I'm not lying, guys. This is like, I have never been felt this bad for this many days in a row, ever. What's that? I hate missing school.
Besides, if you take a sick day, you just feel awful at home.
Exactly. I might as well be awful here. Just really isn't all that different. Oh. No, I wouldn't go that far. Same deal. two sides and an angle. I always think that this is the style that most people screw up. Why, I don't know. I think it's because you have to hit the inverse button. People get freaked out by it. But you know how to set all of it up. And that's what boggles my mind, is that every one of you guys know exactly how to set the problem up, and you don't have any problems doing so. I think it's the fact that you actually have to press a button. Maybe you get overwhelmed by too many choices. I don't know. So to find the hypotenuse, we just have 9 squared plus 12 squared. Hey, that's going to equal 15 squared, so your hypotenuse is 15. It's a triple, 3, 4, 5, if you remember. Finding angle A. Well, if you're at angle A, what's 9 and what's 12? Opposites and adjacent. What trig function is opposite and adjacent? Tangent. So the tangent of angle A is 9 over 12. $36 and thank you. And then you flip along the other side, and you have now the tangent of C is 12 over 9. Because you change positions. The 12 and the 9 now have different relationships via opposites and adjacents. Okay? So you inverse tangent of 12/9. Let's see, so that would be 53/13. Did that one right? Okay. And that's what the stuff looks like. It's just a matter of quite literally picking a spot and going through. Now, what I want to do here, though, is excuse me, is to kind of review also with you guys some of that elevation and depression stuff. So let me give you some of those. No, I want you guys to have those extras. Now you've got another 3 or 4 more examples of things that we've done. Low CN. Data. Yeah, as you guys would rather catch the Chromebook over and trying to write this all down on the screen. No, we click the next couple of things here. I still wanted to let go of your hold. So
Maybe if you put on the website.
did you look on the website?
I mean, right now, it doesn't say anything.
Did you click on the date?
Today
Do
is
you-
the 8th, correct?
Did you not know how to click on the thing and where it says more details?
Oh, more details.
Oh, yeah, right? Did you not know that's how that worked?
Okay, not all more details. Maybe it should be more details.
No, they are always on the more detail.
No, it's not. Yesterday it wasn't. Yeah, that's
No, yesterday it was. What's it? What's that? I got a couple of things to go over. We got a couple of days today. So let's quickly remind ourselves in how we draw pictures and how we set all this stuff up. This is number 2. A ladder is leaning against the wall. the foot of the ladder is 6.5 feet from the wall, and the ladder makes an angle of 74 degrees that is level with the ground. How high up the wall does the ladder reach? Now, excuse me. I find this kind of odd that they don't know how high up, or excuse me, they don't know how high up the ladder will reach, but yet they know how to measure the angle that the ladder makes with the ground. I think that's kind of weird.
Math problems where the person pays with $6.19 when all you needed was $1.12.
Well, that way you get a 5 and a nickel back. Well, 12, no, sorry, we got 6 cents back. Well, then give it 18 cents. Anyway, so you have to know what a wall looks like. You have to know what the ground looks like. And you have to know what something leaning against the wall from the ground looks like. Would you like me to repeat that? So, if the foot of the ladder, now, the foot of the ladder, would that be at the bottom of the ladder, do you think? Or the top of the ladder? It's at the bottom. Because if the foot of the ladder was at the top of the ladder, you're going to fall.
Very quickly.
Because extension ladders literally have feet. Did you know that?
Yes.
They move with the, as they stay flat as the ladder rotates back and forth.
They're little and rubbish.
There's 6.5 feet, and here's your 74 degrees. If you are trying to figure out how high up the wall the ladder will reach, what part of said triangle are you trying to find? Which one? The wall side, which is, in this case, in the diagram, the what part of the right triangle? The opposite, very good. You're trying to figure out the height here on the opposite side. What trig function deals with opposites and adjacents? So we know that I take the tangent of 74 is the opposite over the adjacent. Multiply out. I'm going to guess maybe 9 feet. I'm guessing that it's, I know that it has to be larger than 6.5 feet because 74 degrees will be bigger than the angle that's across from the 6.5. So I don't know, I'm just guessing. How high up the wall does it go? 22.67, I was nowhere near that. There you go. That's a rather tall extension ladder. No, not really.
I'm a big fan of ladders.
No, I'm really not either. But if you think about it, if you think about 22 feet up in the air, that's like your second story gutters. You're trying to put Christmas lights up right about in that area. Well, never mind that. Bless you. What? Sorry. Okay.
Two brothers, two dogs, two parents. Sometimes broken.
Oh, that's right. I remember that. Can I, you guys remember? All right. Another great one for us awesome artistes. If a plane is taken off from a field and it rises at an angle of 8 degrees horizontal from the ground, it flies over a water tower, which means we need to draw some pictures. So, well, you should be able to draw a picture, that way you know what it is. Here's a plane. There's the field. We need an airplane. We'll use a Spitfire. We'll move it to scale. What am I missing? The water tower.
You gotta like turn it angle it up just a little bit so it looks like
There's our water tower. Which means, and it's taken off. So it says it takes off
that looks like a mushroom.
at an 8-degree angle from the ground. So that's your angle of elevation coming up off the horizon. As the plane is climbing, it reaches a distance, it goes a distance of 2,000 feet. Now, is it going a horizontal distance of 2,000, a vertical distance of 2,000, or a diagonal distance of 2,000? Once again, the airplane takes off and it goes this way. That would be a diagonal, because if it was a vertical distance, what would the airplane do?
Crash right into it.
It would go up. If it was a horizontal distance, what would the airplane do?
Run into the water tower.
It would run into the water tower and die. But the good thing is, it would put its own fire out.
Oh.
It depends on if the water tower is actually full or it's been like.
Anyway, it wanted to know how much distance changed from where it took off to where it got to the water tower. So is that a horizontal distance or is that a vertical distance? Horizontal. So in this diagram, we're trying to find this horizontal distance. Is that an adjacent, an opposite, or a hypotenuse as far as the 8 degrees? It's the adjacent. What trig function am I going to use now to find an adjacent, knowing that I have an angle and a hypotenuse? If I'm not mistaken, I know we did this one earlier today. I think you get 1980.54.
Yeah.
So somewhere in June of 1980. Halfway through 1980s, June-ish.
Did you make that joke earlier? Is that why you remember that?
What's halfway through here? So, well, it's still months. The 6th month, 6 out of 12 is 0.5, right?
Yes.
So, halfway through June. Oh. We got into a debate about this in 4th hour. Well, no, if it's 0.5, it's got to be May. I'm like, no, it's not halfway through the year. Okay? Hey, real quick, how tall is the water tower? What do you do? What do you do to figure out what if you got that wrong?
Well, then you gotta do a lot more.
Well, if you're going to figure out how tall the water tower is, knowing that you have a degree measure and a hypotenuse, what are you going to use?
Opposite and
No, what happens if that was wrong?
sine. You're gonna use sine.
Sine, very good. Remember, whenever you're trying to find side lengths, guys, if you only have one side length to start with, you're going to use trig twice to find the other sides. That's an always rule, okay? And I think we got, what was it? 270 something? 278, 279, somewhere around there for the height of the water tower. That seems really high. I don't know what the regular height of a water tower is, but that seems really, really high. We'll go from there. Try one more of these real quick, and then I'll give you some other ones. There are a couple other things I want to look at. Find the measure of the angle of elevation of the sun when a boy is 5 feet tall and casts a shadow 5 feet long. So we need a sun.
Is it a flower? Yeah, sunlight.
There's the sun. The sun's rays are casting a shadow on a boy.
We're boys, yeah, actually, we're not boys. Oh my gosh. Let's look here.
The boy is 5 feet tall.
Kind of short.
His shadow is also 5 feet long. What's the angle of elevation? Now, in all honesty, do you need to know trig to solve that? What is it, Clay? I'm trying to find the angle. Yeah. What kind of right triangle is that? It's isosceles right triangle. Isosceles right triangles always have what for base angles? Right, 45. So the angle of elevation here is 45. It has to be. Because it's an isosceles right triangle, because these both are the same, which means these have to be both 45. Now if you did it via trig, you're still going to do tangent of theta is 5 over 5. So theta is the inverse tangent of 1, really, which is, and you're going to get, so if you forgot special right triangles, trig still works. And there's a reason for that. It's because of the unit circle. And we'll do that next year. Okay? It's fun. Hey, speaking of special right triangles, that's something that you guys tended to have forgotten. So let's review that. It was what? No, it was a couple weeks ago. I know it seems like it was forever long ago that we've done these things, but it wasn't that long ago. Wow. See how fast it is? We're using both of them over the course of the next 2 days. I'll explain it all in 1 second. So what happens here yeah, but I can't count. You should expect nothing but that. So, just to clear up everything on here, what I wanted to do today was to basically get you guys review junk about a day or so ahead of schedule. So over the course of the next 2 days, I expect both of these to be complete. That's what I'm looking at, okay? So if you think about it, there really isn't all that much on there. And it's just all review of everything that we've looked at. So what I want to do is look at number 5 to start with. And try to remind you guys and how to work with special right triangles. Now, when you're dealing with special right triangles, you have to know which of the two triangles you're working with. Well, in this, now number 5, is it a 30, 60, 90 triangle or a 45, 45, 90? Why is it a 30, 60, 90? Because there's a 60 in it. Now, real quick though, look at the problems above it. Does it say anywhere that it's a 30, 60, 90 or anything like that on any of the other triangles? You can't just assume that they are. A lot of you guys did that before when you're trying to find missing side lengths and you're wrong. Excuse me. So, ratios of the sides. Ratios of the sides of these things, guys, come on, I really can't talk much louder, are always in the pattern of x, x root 3, and 2x. All 30, 60, 90 triangles have this exact same pattern with them because all 30, 60, 90 triangles are similar to one another. The ratios of the sides will always be the same. Now, in this diagram, you're given the value across from the 90, I believe. And I think on number 5, across from the 90, it's 4? Is that right?
Yep.
So that means that I put across from the 90, I set this equal to 4. Now remember when we did this a few weeks ago, this just tells me I have a one-step equation to get this common multiplier by itself. How do I undo multiply by 2? Divide it, and you get So that means that everywhere I see an x with the other two ratios, or the other two sides, I just replace it with a 2. So across from the 30 is going to equal 2. Across from the 60 would be 2 root 3. That's all it meant. It didn't matter if it had a root to it, a decimal, a fraction, whatever. Your calculators will do the work for you. Okay? Look at the one below that, number 7. Number 7 is a 45, 45, 90. That one had the ratios of the same, and the same root 2. This one's giving you across from the 90. I believe it's 6.
Yep.
So that means I have to take this x root 2, or x times the square root of 2, and set it equal to 6. Again, it's a one-step equation. How do you undo multiply? You divide. So I divide both sides by the square root of 2. I put that in my calculator, and it will tell me that my answer is 3 root 2. This is that common multiplier of x then. Therefore, everywhere I see an x, what do I put? That's all it is. And that's how we worked with those. So on this sheet, you've got a couple of, using Pythagorean theorem to find missing side lengths. You've got the 6 find the missing side lengths that they have labeled out for you. On the back side, you have the next 8 of them are solved for all the side lengths, just like we did yesterday. And then the last ones are just a couple more of this compounding mixture between two triangles, where you're using 30, 60s and the 45s to get yourselves through. You got those angle of elevation, so you got plenty of things to work on over the course of the next couple of days. Tomorrow in class, we'll just go over questions, make sure we're on the right path for these things. I will remind you guys about how to tell if something's acute, obtuse, and right or right. Did that as well. We'll go from there. All right? Yeah, I want both of those sheets done by Friday.
Okay.